In this video, we're going to be doing a kinematics word problem. Here's the formula sheet. Feel free to give it a shot and keep watching to see the solution. Okay, so here's how to do it. A car's velocity on the highway increases uniformly from 20 kilometers an hour. So this is the starting velocity. You might also hear initial velocity, but I'm going to put V naught here for initial velocity. And this is the ending velocity. So I'm going to put V here. 20 seconds. What variable would this be? Well, this is time, so I'm going to put T for time. And what do they want us to find? The acceleration, so what variable would that be? A for acceleration. Average speed, that's going to be V naught plus V over 2. You can do this when they say it increases uniformly from, they give you an initial velocity and an ending velocity. And distance traveled, that's also what they want us to find, and what variable would that be? Find delta x. Okay, so I'm going to copy the information they gave us real quick. So they gave us V naught is equal to 20 kilometers per hour. V is 80 kilometers an hour. And T is equal to 20 seconds. Okay, so let's start by finding the acceleration. So we have V naught, we have V, and we have T, and we also want to find A. So what formula from this sheet has V naught, V, T, and A? It's this one. So let's go ahead and copy it real quick. So V equals V naught plus A times T. Okay, so before we can use this formula, we need to convert these to meters per second. Right now it's kilometers per hour. We need to change it to meters per second. So how do we do that? Well, how many meters are in 1 kilometer? 1,000. How many seconds are in 1 hour? 3,600. Okay, so this turns into 20 times 1,000 divided by 3,600 meters per second. Okay, so how do we multiply this with the fraction here? I can divide out 20. Okay, and then divide out 20 again. So this becomes 50 over 9 meters per second. And if I do the same thing here, what would I get? Okay, now we're ready to use this formula since we converted V naught and V to meters per second. So V is how many meters per second? 200 over 9 meters per second. How about V naught? What am I going to change this to? 50 over 9 meters per second. How about acceleration? Well, that's what we don't know, so I'm going to leave it as A. And T is how much? 20 seconds. Okay, so we want to figure out what A is. So what should I do to both sides of this equation? I should subtract this from both sides. So we've got 150 over 9 meters per second is equal to acceleration times 20 seconds. And what should I do to both sides of the equation now to get A by itself? Divide both sides of the equation by 20 seconds. Okay, now what does this simplify as? So what's 150 over 9 divided by 20? 150 over 9. Same thing as, if you divide by 20, it's the same thing as multiplying by 1 over 20. And then meters per second divided by seconds. So meters per second and then times 1 over s. Okay, and that's going to be a acceleration. All right, so let's simplify this first. What does this simplify as? I'm going to divide by 10 here, and then divide by 3 here. Okay, so this is 5 over 6, and then meters times 1 is just meters, and then seconds times seconds, seconds squared. Okay, and if we want to write this as a decimal, this would be approximately 0.83 meters per second squared. This is your answer. Okay, now I'm going to get another sheet of paper, and we are going to do the next part. So find the average speed. Okay, so how do we do that? Well, average speed is v naught plus v over 2 if they say that the velocity increases uniformly. Okay, so let's go ahead and write that down. V naught plus v over 2. I'll write, okay, yeah. We'll just change v naught to this, 50 over 9 meters per second. Okay, v gets changed to how much? And then divide by 2. Okay, so this plus this, that's 250 over 9. 250 over 9 meters per second. Okay, over 2. So that would be 125 over 9 meters per second. So it's approximately, double check what this is. I think it's 13.88. Let's see here. Yeah, 13.89 meters per second. Okay. Let's do distance traveled now. Okay, so this time we care about delta x. We have a lot of information now. So actually there are a couple formulas we can use here, but okay, so we already know v naught v. So we could fill in this and this. We also know what? We also know t. Okay, so we can use this formula to figure out delta x. Let's go ahead and do that. Delta x is equal to, I'm just copying the formula here, v naught plus v over 2 times t. And by the way, you can also say that this is the same thing as v average for this problem. Okay, average velocity times time. Okay, so I can plug this in, 13.89 meters per second. And then time is how much again? 20 seconds. Okay. So this times this is how much? 277.8. And then meters per second times second is just meters, because if I multiply this and this, the s's cancel. Okay, so this is your answer. Hey guys, I wanted to revisit the second part of this problem because with driving and speed, you usually talk about it in kilometers per hour. So I converted it back to kilometers an hour, and you can do that by multiplying by 3600 over 1000. So 50.00 kilometers per hour. But the reason why I did this at the end is because all our calculations, all our intermediate calculations are done in meters per second. Like for this formula, when we use this number, we had to use it when it was in meters per second. We don't use this number here. So only do this at the end. And usually you won't even have to do this step. It's just driving is one of those weird problems in high school physics where you might have to do this if you're talking about velocity or if you're talking about speed. But yeah, if I got pulled over by a police officer and they were giving me a speeding ticket, they're not going to be using this number. They'll use this number, but it'd be kind of funny if they used this one.